Morning, all of good morning, all of you. Welcome to Sujendra Rank Zone. Today we are going to start new chapter, that is 11th class thermodynamics and thermochemistry. So far, it is very important chapter. So and it's a numerical chapter. So please listen carefully all the numericals because it's not so easy. So basic converts I have given the notes in this form of PPTs. So please write the notes based on your PPTs. Yes, this is thermodynamics. We're going to start a new chapter and thermochemistry. Very important chapter for all competitive exams. Let us see now what is thermodynamics. Thermodynamics is a branch of physical chemistry, the branch of science or physical chemistry, which deals with the changes in energy or transfer, changes in energy, that is heat energy mainly, or transfer of energy that accompanies physical and chemical processes. It gives a quantitative relationship between heat and other forms of energy. So this is called thermodynamics. So it gives a quantitative relationship between heat and other forms of energy, which is called as thermal energy. Next. So in general, if you take into consideration what is thermodynamics, I'll write it here. It is a branch of, it is nothing but the branch of physical chemistry. It is a branch of chemistry. Simple words I'm writing here, which deals with the study of heat of reactions, which deals with the study of heat of reactions, heat associated and work done, heat of reaction. So these in simple words you can say what is thermodynamics. I hope it is clear. So it is a branch of chemistry which deals with the study of heat of reaction, and it has no effect of rates of reaction. Rates of reaction, it is nothing to do with thermodynamics. So rate of reaction will not deal with thermodynamics, only will deal with heat of the reaction, which is at equilibrium. So thermodynamics is the branch of science which deals with the changes in energy or transfer of energy that accompanies physical and chemical processes. It gives a quantitative relationship between heat and other forms of energy. As I told you, it deals with the heat of reaction mainly and process also. Next. So basic terminology in a thermodynamics. System. System is a part of the universe under study, very important. So if you are studying any system, there is nothing but under study means under examination. So if you are taking, for example, water is heated in a container, in this water is a system because we are studying about the water in a container. So water is heated in a container. So this is called system. What is system now? System is a part of the universe under study or examination. So this is called system. Other than this, next boundary, surrounding and boundary. What is surroundings and boundaries? Surrounding is a part of the universe apart from the system. You can underline this word. Apart from the system, whatever is there, that is called surroundings, but close to the system. Boundary, an imaginary or a rigid line. Imaginary or a rigid line which separates the system and surroundings is known as boundary. Here, container is called boundary. Water is the system and walls of the container form the boundary, and rest of the universe is called surroundings. Rest of the universe is called what? Surroundings. So these are the basic terminologies in thermodynamic systems. What are those? System, surrounding, boundary. What is system? Which is under study. Uh, the medium which is under study is called system. What is surrounding? Surrounding is a part of the universe apart from the system. Apart from the system means it is other than system but close to the system. An imaginary rigid line which separates the system and surroundings is known as boundary. An imaginary or a rigid line which separates the system and surroundings is known as boundary. Example, water is heated in a container. So water is the system, walls of the container form the boundary, and the rest of the universe is called surroundings. So this is called the basic terminology in thermodynamics. I hope it is clear. Next, types of system. We have open system, closed system, isolated system, homogeneous system, and heterogeneous system. So these are the different types of systems we have in thermodynamics. One is open system, closed system, isolated system, homogeneous system, and heterogeneous system. All these are very, very important. So examples they'll ask in the examination. Next, what is an open system? A system in which both matter and energy, very, very important here, both matter and energy can be exchanged with the surroundings is called a open system. A hot liquid in an open vessel. So if we take a hot liquid in an open vessel, what happens? So the vapors of the liquid will be evaporating towards the atmosphere, that is just out of the system. So that is nothing but what matter is going, and also energy is also going. So how matter is going? As I told you, vapors of the liquid is going to the surroundings from the open vessel. So it's going to surroundings. So in this called, it is called, the vapors are nothing but what? It is the matter of the system. Nothing but what? Matter of the liquid. So it is called matter. And one more, energy. So how energy? So heat energy is lost. Heat energy is lost by the system to the surroundings. Heat energy is lost by the system to the surroundings. So heat is also generated because it lost its heatness. After some time, you will see that it will become less heat when compared to the total heat. So that's why a hot liquid in an open vessel is nothing but open system. Or you can say a hot tea in a cup. Hot tea in a cup is also an example for open system. So hot tea in a cup means what happens? The vapors of the tea is going away, going to the atmosphere, and so even you cannot no need to say hot tea in a cup. Also, simply you can say hot liquid in a cup. So this is called energy. So since heat is a form of energy, so we'll call it as energy. So this is called a system in which both matter and energy can be exchanged with the surroundings, because it is giving heat energy to the surroundings, due to which what happens? It lost its heat. The liquid lose its heat. So a hot liquid in an open vessel is nothing but, it is called a system, that is open system. A system in which both matter and energy can be exchanged with the surroundings is called a open system. Example, a hot liquid in an open vessel, vapors of the liquid is going to the surroundings, because from the vapors matter is also going out. So heat energy is lost by the system to the energy. So I hope it is clear. So this is the example for open system. Next we'll see what is next system, that is closed system. So a system in which only energy can be exchanged, not the matter. Only energy can be exchanged, but not the matter with surroundings, but not matter with surroundings, is called a closed system. Example, a hot liquid in a closed vessel. A hot liquid in a closed vessel, what will happen? So as the vessel is closed, matter will not go out. Matter is not exchanged. Matter is not exchanged, but only hot liquid in a closed vessel means what happens? It loses heat energy to the surroundings. Heat energy, it loses, it loses heat energy to the surroundings. So this is nothing but what? This is called what? A closed system. A hot liquid in a closed vessel is called a closed system. It is not giving matter to the surroundings, but only it loses its heat energy to the surroundings. So that's why only energies can be exchanged, but not the matter. I hope it is clear. Next, what is an isolated system? A system in which neither energy nor matter can be exchanged with the surroundings is called isolated system. So neither energy nor matter will be exchanged to the surroundings is called isolated system. So example, thermoflask. You already know thermoflask is almost like an isolated system, because in thermoflask, if you keep tea, so if you keep hot tea in thermoflask, what happens? The heat is not even it will neither lose heat energy nor matter to the surroundings. That's why it is a perfect isolated system. And a perfect isolated system does not exist. So thermoflask almost acts as an isolated system, because some sort of heat will be is losing from the thermoflask. So that's why we can say it is not 100% perfect. It is only a isolated system, but a perfect isolated system does not exist. So this is called thermoflask. What the use of this thermoflask? We will use coffee or tea in thermo. We'll keep coffee or tea in thermoflask, so that what will happen? It in thermoflask, what happens? Hot things remains hot, and cold things remains cold in the thermoflask. after for several hours. So that's why this thermo flask almost acts as an isolated system. A system in which neither energy nor matter can be exchanged with the surroundings is called an isolated system. I hope it is clear. So open system, closed system, isolated system. Next we'll see homogeneous system. What are homogeneous and heterogeneous systems? Homogeneous system is a system in which all the components of the system are in the same phase. Example, mixture of gases. Air is a mixture of gases. So it is a homogeneous system. Water plus alcohol is also a homogeneous system because both the solute and the solvent are what is it, water and alcohol both are in liquid state. So if in a system in which all the components of a system are in the same phase, we'll call it as homogeneous system. What are heterogeneous systems? Heterogeneous system is a system in which the components are in the which the components of the system are in different phases. So mixture of oil and water, benzene plus water, etc. These are all the examples for heterogeneous system. Heterogeneous system is in which the components of the system are in different phase. One will be in solid, one will be in liquid, another will be in gas, or liquid and gas, or solid and liquid. So anyway, on the whole, the particles in the system, that is the components of the system, are in different phases. Phases means solid, liquid, and gaseous phase. And here the components of the system are in the same phase. Example, water plus alcohol solution is a homogeneous system because water is a liquid, alcohol is a liquid. Air is a mixture of gases, so all in the air it contains all the gases in the mixture. So that's why mixture of gas is also called a homogeneous system because all are in gaseous phase and so on. I hope it is clear. Next, what is state of a system? Very, very important. From here onwards, it is important for objective. State of system. What is a state of system? A state of system. The state of system is a condition under which the system exists. The set of measurable properties like pressure, volume, and temperature constitutes the state of the system. So this is called state of system, in which is the condition under which the system exists. We can say what is the state of system, solid state or liquid state or gas state. That is called state of system. So the state of a system is the condition under which the system exists. How it exists as whether it is solid or liquid or gas. So the set of measurable properties for that system will be like pressure, volume, and temperature constitutes the state of the system. I hope it is clear. So we'll say the system is at 100 degrees C. We'll say the pressure is at 1 atmosphere, volume of the system, everything we can say. So that is called state of the system. Next, what are thermodynamic variables of a system? Very, very important. So what are the thermodynamic variables of a system? What are the thermodynamic variables of a system? Let us see now. So they are classified into the thermodynamic variables are the properties which are used to describe the system. They are classified into state variables and path variables. So state function or path function, we can say it is called also called as state function and a path function. So it is state function and a path function. Next. So what is a state function or state variable? It is a property whose value depends only on the present state of the system. Very, very important here. It is depending only on the present state of the system, and it is independent of the previous history of the system. So example, pressure, volume, temperature, etc. are called as state functions or state variables. So what are pressures? It is independent of previous history. It is only depending on the present state of the system. Present state means we can say temperature 100 degrees C. Previously it can be 0, minus, or 200, 500 also. Now what is the temperature of the system we'll ask means it is 100 degrees C. So it is nothing but what example I'm giving. So it is a state function. Volume also 1 liter, 2 liters, its value keep on changing, but at a particular point its value is same, its value is same, that is constant. So it is independent of the previous history of the system, and pressure is also the same. Some of the properties such as internal energy, enthalpy, entropy, and free energy, which will be discussed later, are also called state functions. So internal energy, what is internal energy? What is enthalpy? What is entropy? What is free energy? We'll discuss all these 4 points in the next section, means the next topic when it comes. But these are also other examples of state function. So how they'll ask question based on the state function? They will not ask any definition for this in the competitive exam. They'll ask which are the following are state functions, which are the following is a state variable or state function. They'll give four different options based on, they'll give work, energy, pressure, volume, temperature, anything they can ask. So in that only one will be state function, remaining three will be non-state functions. So I hope it is clear. So they'll ask MCQ based on this, which of the following is a state function, which of the following is a state function, which of the following are state functions. They'll give multiple options also. So it's very important to note down the examples. If you remember the definition, it's well and good. If you don't remember the definition, at least you have to remember the examples. It is a property whose value depends only on the present state of the system, and it is independent of the previous history of the system. Example: pressure, volume, temperature, etc. Internal energy, enthalpy, entropy, and free energy. Entropy and Gibbs free energy. So all these nothing but they are the examples of state functions. So collect more and more examples of the state function. If you can understand the definition, easily you can remember. So what is state function? It depends only on the present state of the system and is independent of the previous history of the system. How it comes to the system, that is called, it is nothing but path system. It is nothing but what, how that system came to this path. The path of the system is not required. Path is not required. So how it attains this much temperature, how it attains this much volume, how the system attains this much pressure. So the path of the system is not required. So that is called state function. I hope it's clear. So state function, state variables, both are same. Next, path functions. The function whose value depends on the path. So how does it came to that position? The path followed to reach a particular state of the system is known as path function. For example, suppose if you take iodine solid, changes to iodine gaseous vapors. So this is done by the means of, so here iodine changes to iodine gas. So that is nothing but we'll say either this is called only iodine gases. If you take, this is called state function. Only iodine solid you will take, this called state function. But if you take, how does it change to iodine solid to iodine gas? By the means of sublimation. So sublimation is called the path function. So by the means of sublimation only, it has come to, what is sublimation? The process in which a solid is directly changing into gaseous state. A solid is directly changing into gaseous state is called sublimation. So sublimation is called path function. So the function whose value depends on the path followed to reach a particular state of the system is known as path function. And here in physical process, we'll say it is called work done. So example, work is heat and work are nothing but path functions. Heat of the system and work done by the system or work done on the system. So work of the system and heat and work of the system are nothing but what? Path functions. So which of the following are path functions? Which are the following are state functions? They'll ask MCQ in the competitive exam. So both examples you have to collect as many as you can from the textbook and other materials. So what is path function? Once again, I repeat, the function whose value depends on the path followed to reach a particular state of the system is known as path function. So I hope it is clear. Next, what is heat? So the energy transferred from a heart, the energy transferred from a hot body to a cold body without any mechanical work is known as heat. So it is nothing but the transfer of uh, energy. That is nothing but the heat is nothing but a transfer of energy from a body at high temperature to a body at low temperature. Any without doing any mechanical work is known as heat energy. It is an energy exchange between the system and the surroundings due to a difference in temperature between them. As I told you, it is the energy exchange between the system and the surroundings. Suppose if you take hot liquid in an open vessel, what happens? The liquid gets cooled after some time because it exchanges energy to the surroundings. So that is nothing but what? It is the energy exchanged between the system and the surroundings due to a difference in temperature between them. It is called as heat. So always, what is heat? Always heat transfers from a, heat is a form of energy which is transferred from a body at high temperature to a body at low temperature, or you can say which is transferred from a hot body to a cold body. So without any mechanical work is known as heat. Unit of heat is calories, joules, ergs, Newton meter, liter, atmosphere, etc. So all these are the units of heat. The units of heat is important because the interconversion of heat is also important. So calorie, joule, ergs, Newton meter, liter, atmosphere, etc. So what is 1 calorie? 1 calorie is equal to 4.2 joules. 1 calorie is equal to 4.2 joules. 1 joule is equal to 10 to the power of 7 Elks. So these conversions is very, very important. So all these conversions are important. Newton meter and joule is the same. 1 Newton meter is also equal to 1 joule. So liter atmosphere, all these conversions I'll give you later. So this is called units of heat. I hope it is clear. So what are the units of heat? Calorie, joule, erg, Newton meter, liter atmosphere, etc. So as I told you, 1 joule is equal to 1 Newton meter, which is also equal to 10 to the power of 7 Elks. It is equal to 0.23990 calories, because 1 joule is less than calorie. 1 liter atmosphere, this is very important. 1 liter atmosphere is equal to 101.3 joules, and is also equal to 24.206 calories. If you don't know these conversions, you cannot do numerical substitution. Numericals, for solving numerical, it is important. For solving numericals, it is important because they'll give heat energy in the form of joules. Or for solving numericals, these units are very important. 1 joule is equal to how much? So this table is very important. 1 joule is equal to 1 Newton meter, which is also equal to 10 to the power of 7x, which is also equal to 0.2390 calories. 1 calorie is equal to 4.2 joules or 4.184 joules. 184. So 1 liter atmosphere is 101.3 joules, and from joules you can easily calculate calories. So heat is a path function. What is heat? Heat is a path function. So these conversions are very, very important. If you don't know these conversions, you cannot substitute the numericals easily, and you will not get the answer also, because they'll give the uh, heat of the system in liter atmosphere. They ask the answer in joules, so automatically you have to change the liter atmosphere to joules. So when they have given the answer in Elks also, you have to convert it into joules or calories also. So they can give mainly joule, liter atmosphere, and calories. All the three are important. That's why you have framed the notes like this. I hope it is clear. So this conversion is most important. Please note it down in your classwork immediately. It's very, very important. Next, work. What is work? Work of expansion is the energy exchange between the system and the surroundings due to the difference in pressure between them. So work is nothing but it's also a form of energy, but it is exchange between the system and surroundings due to the difference in the pressure between them. So this is called work done. So work is done by a system or work is done on the system. Suppose if heat is lost to the surroundings, then it is called work is done by the system. So if heat is lost, if heat is gained by the surroundings, then what is happened? So work is done on the system, sorry, by the system, and work is done by the system and of the system. I hope it is clear. So, what is work? It is nothing but the energy exchanged, work done by the system, work done on the system. Both are different. What is that? We'll discuss. So, it is the energy between exchanged between system and surroundings due to the difference in pressure between them. So, work is equal to force into displacement. Work is also a path function, and as it is also nothing but energy, it is measured in joules, calories, ergs, etc. Thermodynamic properties of system. The properties which describe a system are known as the thermodynamic properties of a system. These are of two types: intensive properties, extensive properties. These two are very, very important. They'll ask which of the following is an intensive property, which of the following is an extensive property. So both these are examples. They'll ask for examples. They'll ask for MCQs. Examples as MCQs they'll ask in the competitive exams. So please refer all the examples of this. If you understand the definition easily, you can understand the examples. Let us see what is intensive system and what is extensive property. So extension properties. These are the properties of a system which depend upon the quantity of matter. So what are extension properties? These are the properties of a system which depends on the quantity of matter. It's very important. Quantity of the matter present inside the system. Example, mass, volume, internal energy, enthalpy. Enthalpy is nothing but heat. Entropy, change in randomness. So free energy, heat capacity, etc. All these are the examples of extensive property. It is depending on the matter of the system that is present, quantity of matter present in the system. Example, you can say mass. You can say mass is equal to, we can say 1 kg, 2 kg, 3 kg. They are different. So it can be anything. So volume, if you take 1 liter, 2 liters, 10 liters, etc. So internal energy, change in internal energy is in the form of joules. Enthalpy, joules. Entropy, change in that is randomness. And free energy, that is Gibbs free energy. And heat capacity. All these are the examples of extensive properties. So examples are important for MCQs. So all the examples, collect as many examples as you can. Examples are important. They'll ask as MCQ. Which of the following is an extensive property? Which of the following is an intensive property? So that type of question they'll ask in the competitive exam. So you should remember. So what is an extensive property? It is a property of the system which depends upon the quantity of matter present in the system. Quantity of matter, it is mainly important is quantity of matter. So it depends on the quantity. Next, intensive property, which are independent of quantity of matter of the system. These are the properties of a system which are independent of the quantity of matter in the system. So this is called intensive property. So example, temperature. Why temperature is called an intensive property? Because we'll say the temperature, room temperature is 35 degrees C or 25 degrees C, for example. We'll say room temperature is 25 degrees C. So this is called room temperature, and it is independent of the number of rooms, that is one room or two room or size of the room. So room temperature 25 degrees, hence 25 degrees C is nothing but what? Is that it is depending on, which is independent of quantity of matter. Either you take small room or big room, it is the temperature is same, that is 25 degrees C. So that's why it is called intensive property. Intensive properties are those which are independent of the quantity of matter in the system. Second, pressure. So you can say atmospheric pressure is 1 atmosphere. So 1 atmosphere is an atmospheric pressure. What is the meaning of this? 1 atmosphere is the atmospheric pressure means here. What is the meaning of this here? So you take whether in Hyderabad you take 1 atmosphere, or in India you take, in the world you will take 1 atmosphere. So pressure is also depending, is independent of the quantity of matter. Density, I'll say the density of iron is 5 grams per centimeter cube. So you take one sheet or 1 kg or 100 tons of kg, what is the quantity? It is not independent of quantity because the density is same, that is 5 grams per centimeter cube. Viscosity, concentration, surface tension, boiling point, because you see boiling point of water, you take 1 kg of water, 100 kg of water, it is boiling point never change, that is equal to 100 degrees C. Melting point also 0 degrees C. So not only water, so boiling point, melting point, surface tension, pressure, density, viscosity, concentration of the solution. All these are coming under intensive properties. I hope it is clear. Intensive property is most important. So intensive property is not depending on the quantity of matter. It is independent of quantity of matter. It is independent of quantity of matter is called as intensive property. For example, I'll say 5 rods, 5 steel rods of 1 ton. 5 steel rods of 1 ton means it is nothing but what? The density, the thickness will be 5 only for construction. So 15 16 depending on the size of the pillar we'll use. So that is nothing but what? Density. So the density will never change. So it is nothing but what? It is nothing but intensive property. Density will never change in sense density is a constant quantity of that particular system. So temperature, boiling point, melting point, all these are coming under intensive properties. I hope it is clear. Extensive property depends on the quantity of matter, whereas intensive property independent of quantity of matter in the system. So I hope it is clear. So these are called system, intensive property and extensive property. I hope it is clear. Next. So ratio of two extensive properties given intensive property, very, very important. The ratio, if you divide an extensive property, two extensive property, it will give you an intensive property. Example, density is equal to mass by volume. Density is nothing but what? Mass is an extensive property, volume is also extensive property. So density is intensive property. So intensive, extensive, and extensive. So if you divide two extensive properties, you will get an intensive property. Molar volume also, total volume is nothing but extensive, number of moles is also extensive. So by dividing extensive property to extensive property, the ratio of two extensive properties gives an intensive property. Molar volume is fixed. 1 mole of any gas occupies 22.4 liters. So that is nothing but what? Molar volume. It is nothing but it is fixed. It is not depending on the quantity of matter. I hope it is clear. Any molar property, molar heat capacity, molar mass, 1 mole of a substance are nothing but intensive because since the quantity of matter is specified, it is the independent of quantity of matter. It is specified. So I hope it is clear. So this is nothing but the ratio of two extensive properties gives an intensive property. Next, how to identify extensive or intensive properties. If a system in a particular state is divided into two equal or unequal parts, the properties which have value equal to the original value of the property for the whole of the system are called as intensive properties. As I told you, the intensive property will never change its value. So how to identify the intensive property? If a system is in a particular state, for example, in say water, ice, or you can say mercury is a liquid. So liquid state, any state, is divided into two equal or unequal parts. The properties which have a value equal to the original value of the property. So if we take, for example, if we take mercury liquid, you separate them in thermometer. What happens? Its density will not change, even though if you separate them. So it is nothing but what the properties which are equal to the original value of that property for the whole system of the for whole of the system are called intensive properties, and the properties which have different values from the values for the whole of the system are called as extensive property. I hope it is clear. So this is called intensive and this is called extensive property. In this way, you can identify intensive property as well as extensive property. Next example, you can say here 300 kelvins, 300 kelvins at the start of the system. 1 liter, 1 liter, it becomes 2 liters. 1 atmosphere, 1 atmosphere. If you divide them into two equal halves, then what is this? The temperature, pressure, density of the gas, concentration of gases, molecules, etc. In the two parts will have the same value as that for whole of the system, because the temperature will never change, pressure will never change, density, concentration. Whereas hence, these are intensive properties. While the volume, mass of gas, total energy of the gaseous molecules, entropy of gas, etc., the two parts will be different from the values of these properties for the whole of the system. Hence, these are called extensive property, which will change volume, mass of gas, total energy of the gaseous molecules, entropy of the gases, etc. So, in the two parts will be different from the values of these properties for the whole of the system. Hence, these are called extensive properties. So I hope it is clear what are intensive, what are extensive. So next, we'll continue with the same class in this lecture. We'll do now next topic. So this is about systems. I hope it is clear. So what are systems we have discussed so far? We'll continue with the next topic in this chapter. Second lecture, thermodynamic equilibrium. Very, very important. What is thermodynamic equilibrium? We'll discuss now. When there is no change in any observable or measurable property of a system with the time, then the system is said to be in thermodynamic equilibrium. So if there is no change or any observable or measurable property of a system with respect to time takes place, then we can say the system is in thermodynamic equilibrium. Thermodynamic equilibrium consisting of three types of equilibria. One is mechanical equilibrium, thermal equilibrium, chemical equilibrium. Mechanical means the mechanism of the reaction. Thermal means with respect to heat, and chemical equilibrium with respect to chemical reactions. Let us see what are the things. So 1 liter, 1 atmosphere, 300 kelvins, PVT, pressure, volume, and temperature. Now, what is mechanical equilibrium? There should not be any pressure gradient with time or with space for any ideal gas system. For a liquid system, there can be a pressure gradient with space, as pressure at the bottom of the container in which a liquid is filled with will be greater than the pressure at the surface of the liquid. Again, I'm repeating this statement. For a liquid system, there can be a pressure gradient with space, as pressure at the bottom of the container in which a liquid is filled. So the pressure at the bottom will be always greater than the pressure at the surface of the liquid. So at the surface of the liquid, the pressure is less. So this is nothing but what mechanical equilibrium. So there should not be any pressure gradient with the time or with space for any ideal gas system. So if a system is having no any pressure gradient or with respect to time, we can say, or with space for any ideal gas system, it is called as mechanical equilibrium. So mechanical equilibrium. So this is called pressure of the gas and the surface massless movable piston will be kept here. There should not be any temperature gradient in the disk systems. Thermal means with respect to temperature. Temperature may have different values at different places, locations in the system, but it should remain constant with respect to time. So this is called temperature is equal to constant. Next, chemical equilibrium. There should not be any concentration gradient of the species in the system. So that is called chemical equilibrium. Now, types of thermodynamic processes on the basis of state conditions. So thermodynamic process. So what are the different types of thermodynamic processes? All these processes are very, very important. These processes are very, very important because they'll ask in examinations. So what is thermodynamic process? It is a process in which a system from one state of the thermodynamic equilibrium changes to another state of thermodynamic equilibrium. So it is a change in system from one state of thermodynamic to another state of thermodynamic. So there can be infinite types of thermodynamic processes, out of which the following are important. First one is isothermal process. It is a process during which the temperature of the system remains constant. If the temperature of the system remains constant, it is called as isothermal process. So in isothermal process, T is equal to constant. Since T is equal to constant, delta T, that is change in temperature, is always zero, because since temperature has no change, so delta T is zero. This value they'll ask in the examination. So in an isothermal process, which of the following is correct? So they'll say delta T is equal to zero. So that is the right option. It is a process during which the temperature of the system remains constant. That is called isothermal process. Examples we can discuss. Isochoic process. It is a process in which the volume of the system remains constant. What is constant here? Volume of the system. That's why delta V, E or dV, or V is equal to constant, or delta V is equal to zero. So here V is equal to constant. V is not equal to zero. V is some value, but delta V becomes always zero because there is no change in volume in the system takes place. Isobaric process. It is a process during which the pressure of the system remains constant. So delta P is equal to zero and P is equal to constant. So where P is called pressure. Next, adiabatic expansion or adiabatic process. It is a process during which there is no exchange of heat. There is no exchange of heat between the system and the surroundings. It is called adiabatic process, just like thermoflask. So Q is equal to zero. Q is equal to zero. What is Q? Q is called heat. Heat energy is equal to zero. So as there is no change in heat, exchange of heat between the system and surroundings takes place. So Q is equal to zero. I hope it is clear. So these are the conditions of the system. Next, what is a cyclic process? It is a process in which the system returns to its original state after undergoing several changes in the state of the system. So it starts with, for example, here I say, let us take a system starts at A, changes to B changes to C finally returns to A. Then it is called what? Cyclic process. Cyclic process means the initial and the final point is same. So it is a process in which the system returns to its original state after undergoing several changes in the state of the system. It is called cyclic process. The change in all state functions is zero in a cyclic process. Very, very important point. In a cyclic process, the change in all state functions. What are the state functions we have? Change in temperature, change in volume, and change in pressure. These are all called state functions. They are nothing but equal to zero. I hope it is clear. So in a cyclic process, change in temperature, that is delta T, change in volume, that is delta V, and change in pressure, that is delta P, is always equal to zero. This point is very important. They can ask in the objective. I hope it is clear. Next, graphical representation of different types of processes. First, we have isobaric process where volume is constant. That's why here, since volume is constant for this graph, so this is called isobaric because V is equal to constant and dV is equal to zero. Next, this is called isothermal process because at constant temperature. Because as the this with respect to boils, if you take into consideration this, as the pressure increases, volume decreases, or volume increases, pressure decreases. So that's why it is called isothermal process. Isothermal because as the volume increases, pressure decreases. Just if why it is isothermal? Because volume increases, pressure decreases. Pressure decreases at constant temperature. At constant temperature. That is nothing but what? Boyle's law, which are done in states of matter. So that's why it is called isothermal process. Next, adiabatic process, where heat is kept constant. Heat is equal to, that is Q is equal to zero. This is called the graph for adiabatic process. Less pressure because less heat is given. So less pressure and decrease in pressure is more, less. So next this is volume and this is pressure. This is called isochoic process. What is isochoic process? At constant pressure. So pressure remains constant. The pressure remains constant. There is no change in pressure. So that's why it is called isochoic process. So I hope it is clear. So all the four process, this graph they'll ask in the examination. Very, very important in complex exams. They'll give one graph. They'll say whether it is isobaric, isochoric, or isothermal, or adiabatic process. I hope it is clear. Isobaric process means volume remains constant, dV is equal to 0. Pressure remains constant, pressure decreases at constant temperature, volume with the increase in volume. So that is called isothermal process, which is also called as Boyle's law. Next, heat remains constant, Q is equal to 0. And isobaric process, what is constant here? P is constant. Pressure is constant. P is equal to constant. So this is called isochoric process. Cyclic process, I told you, A starts with A to B, B to C, C to A again. So this is initial and the original state, then the final state is same. That is starting with A and ending with A. So it is called cyclic process. In cyclic process, what is zero? Delta V is equal to 0. Delta P is equal to 0 because initial and final state is same. So delta T is also equal to 0. So since the initial and final state are same, we can say all these parameters are 0. That is change in volume, change in pressure, change in temperature is always 0 in cyclic process. I hope it is clear. So these two graphs are very, very important. They're asking objective questions. Next, types of thermodynamic process on the way process are carried out. Reversible process. It is a process carried out infinitesimally slowly such that the system and the surroundings are in thermodynamic equilibrium with each other at every stage of the process. So the process can be exactly reversed at any stage by an infinitely small change. So by reversing the conditions, we can say it is called reversible process, just like reversible reaction. So if the process is reversed by changing the conditions, by reversing the conditions, we'll say it is called a reversible process. The difference between the driving force and the opposing force is infinitely small so that the process takes place at infinitesimally slow rate. So F driving minus F opposing should be equal to dF and dF should be equal to 0. Or P external is equal to P internal plus or minus differentiation of P. So an ideal reversible process will take infinite time to get completed. Strictly speaking, there is no ideal reversible process in nature. So we do not have this process because it's very difficult to obtain. Next, to get an idea of a reversible process, we can consider the following system. An ideal gas is enclosed in a container with the help of massless piston, on which a pile of sand having particles of negligible mass is placed. So this is the pile of sand placed on the system. Then what happens, you can see here. To carry out a reversible expansion, we will slowly decrease the mass of the sand, let us say by removing the particles one by one. The expansion of the gas will therefore take place at an infinitesimally small rate, and we can assume the system to be always in thermodynamic equilibrium. So the expansion be the reversible type. So if you change the conditions, it changes the expansion. It is expansion takes place in the reversible side. So this is called irreversible process. And irreversible process, it is a process carried out in a at a finite rate such that the system and the surroundings are not at equilibrium with each other. They are not at all equilibrium with each other. This point is important. They'll ask statement-based question from these two processes. Statement-based question. Which of the following is true regarding reversible process and statement based questions they'll ask in examination objective. They'll give 3 to 4 statements, which is true, which is false, they'll ask. So the process cannot be exactly reversed at any stage by infinitesimally small change. So system may be in thermodynamic equilibrium at some finite number of intermediate stages. For example, reversible expansion of a gas and moles of a gas, reversible expansion. Next, there is a finite difference between the driving force and the opposing force so that the process takes place with a finite rate. Irreversible processes get completed in a finite time. At intermediate stages of the irreversible process, the different state functions such as pressure, temperature, etc. are not defined. All real processes are irreversible. So whatever process we have, they are irreversible because the temperature will change, volume will change, etc., etc., etc. So I hope it is clear. Next. So if the stopper placed over the piston is removed, then the piston will move with almost infinite acceleration upside and keep moving to a piston where the pressure of the gas becomes equal to the external pressure. So the piston will move on keeping like just like pressure cooker. If you take it is a reversible process. If you cook rice in the pressure cooker, you'll get it, but you'll not get the again. You'll not again get the rice in it. So since the process gets completed in a finite time and since there was finite difference between the driving force and the opposing force, the process becomes irreversible. So this is called irreversible process. Now let us check some questions based on this concept. Question number 1. A system of ideal gas was put through series of changes as shown in the diagram. Temperature at points A, B, and F is 80 degrees, whereas at that of point C, D, E is 40 degrees. So they have taken a pressure as well as volume and they are given a temperature. So it is a cyclic process. We'll say A, B, C, D, E, F, G. So it is again coming to A. So it is a cyclic process. First, by seeing the diagram, you can say it is a cyclic process taking place at different stages. First, it stages from A to B, then B to C, then C to D, then D to E, and E to F, and F again back to A. That's why I told you this is a because the end point and the starting point are same. We'll call it as a cyclic process. We'll call it as a cyclic process. So a system of ideal gas was put through series of changes as shown in the diagram. Temperatures at A, B, and C is 80 degrees C. So the temperature is 80 degrees C at constant temperature. This is A, B, and C temperatures. And temperature C, D, E, sorry, A, B, and F, sorry, A, B, and F. This is A, B, and F. It is nothing but A, B, and F. It is nothing but 80 degrees C. And C, D, E is nothing but 40 degrees C. Now, what is the question they're asking? We'll just discuss now. Specify the type of change at each step. At each step, what is the type of change? A to B, what is the change? Let us discuss now and go to back. So A to B, simply easily we can say it is at constant volume. So A to B is constant volume. So it is called isobaric process. A to B is called what? Isobaric process. A to B. B to C. B to C is called with the increase of temperature, volume pressure decreases gradually. So it is nothing but temperature, constant temperature. So it is called isothermal. B to C is called what? Isothermal process. C to D, it is constant volume. So C to D is nothing but what? It is not a constant volume, is isochoric process. So this is constant pressure, no? Constant, this is constant pressure. So it is nothing but C to D is what? Constant pressure. There is no change in pressure. Sorry, change in volume is not there because pressure remains constant. A to B is pressure remains constant, no? Volume remains constant. Volume does not change. Pressure remains constant. C to D is also pressure. So it is called isochoric process. And D to E, change in D to E. D2 is constant pressure. Constant pressure means again isochoric. And E to F, adiabatic. A to F, isochoric. And so on. So like this, we have to see the process. So let us see the answer now. This for the change of each type, each step. What is the value of delta U for overall process? Delta U means change in internal energy. So delta U becomes zero because for cyclic process, delta U change in internal energy because it's a cyclic process. So delta U becomes zero. Very, very important. Because since it is a cycle, what is delta U? Change in internal energy. Change in internal energy is called delta U. And since the original and since the starting process system of this starting system is A and final system is also A, so there is no change in internal energy. So change in internal energy delta U is equal to zero since it is a cyclic process. Next, at which point is the number of gas molecules are maximum? At which of the point is the number of gas molecules are maximum? At the point where the volume is maximum. It is called gas molecules is maximum. I hope it is clear. So this topic we have discussed and we'll discuss more questions based on system and surroundings. So let us see now. Question number 2. I'm writing it on the board. Please note it down. Which of the following very, very important chapter, so that's why I'm giving best questions. Just please wait down. So I hope it is clear now. Now we'll discuss the questions now. Question number 2. Question number 1 is finished. So question number 2. An adiabatic expansion. An adiabatic expansion an adiabatic expansion of an ideal gas always has of an ideal gas of an ideal gas always has gas. So option 1 always has, first one, constant temperature. Second one, Q is equal to 0. Third one, W is equal to 0. Fourth one, delta H is equal to 0. So the answer is Q is equal to 0 because adiabatic expansion of an ideal gas always has Q is equal to 0. Constant heat. Constant heat. I hope it is clear. Next question. Question number 3. Which of the following is a path function? Which of the following is a path function? Which of the following is a path function? Option A. So already you know path function. It depends upon the path. So option A, it is internal energy. Option B, enthalpy. Option C, work. And option D, entropy. So entropy, enthalpy, internal energy is not a path function, it is a state function, and work is a path function because how the work takes place, that is important. So that's why. So it depends upon the path of the system. So that is why work is called path function. Work and heat are path functions. Whereas internal energy, enthalpy, entropy are not path functions. They are nothing but state functions. So like these questions, they will ask in the examination. So please note it down. Next question, question number 4. Question number 5, sorry. Question number 5. For a cyclic process, the condition is what is the important condition for a cyclic process? First option, constant in temperature, sorry, delta U is equal to 0. Second option, delta H is equal to 0. Third option, delta U greater than 0 and delta H is also greater than 0. Fourth option, both 1 and 2. So answer is fourth option because for a cyclic process, Already we know change in internal of system is equal to 0, change in heat also system is equal to 0 because the starting point and the ending point is same. That starting system and the ending system is also same. So that's why it is called a cyclic process. So I hope it is clear. Question number 6 now. Question number 6. Next, which is an irreversible process? Which is an irreversible process? Option 1, they have given options. Mixing of two gases by diffusion. Mixing of two gases by diffusion. Next, option 2 is option 2. Dissolution of NaCl in water. Dissolution of NaCl, that is salt water. Third, option 3, burning of coal. Burning of coal. Option 4, evaporation of water. Evaporation of water. At 373 kelvins. They have mentioned temperature and 1 atmospheric pressure. And 1 atmosphere pressure. This is a condition they have given. So options, option A, 1 and 2 are correct. Option B, this is MCQ with more than one correct option. 3 and 2 and 3 are correct. Option B, this question is very important. Option B, 2 and 3 are correct. Option C, 1, 2, 3 are correct. 1, 2, 3 are correct. Option D, 1, 3, 4 are correct. So what is the final answer? We have to check it now. So let us see, discuss now. Mixing of two gases by diffusion is nothing but what? Mixing of two gases by diffusion is nothing but, it's an irreversible process because we cannot get the two gases back separately. Next, dissolution of salt in water. If you heat, what happens? Automatically, salt gets evaporated first, then water will be left over. So this is not a irreversible process, it's a reversible process. Again, we'll get sodium and water. Next, burning of coal. It is also burning of coal. If you take, when coal is burnt in air, it forms carbon monoxide, carbon dioxide. So mainly carbon dioxide. Again, that from that carbon dioxide we cannot get back. We cannot get back carbon, and so it is a irreversible process. So first, third, and evaporation of water at 370 kelvins and what atmospheric pressure. Again, you will not get the water back at the same temperature. So 1, 3, and 4. So option is D. Only dissolution of 1, 3, and 4. No, is wrong. Let us see now. So if you take into consideration, dissolution of sodium chloride in water is a irreversible process. I'm taking it here, please note it down. And the burning of coal is irreversible process. And what is this? Mixing of gases by 1, 2, 3 are correct. So option is C. Fourth one, evaporation of water, you get back again by cooling it. So answer is 1, 2, 3 only. 1, 2, 3. I hope it is clear. Next question. Next question. Count it down. Delta U is equal to 0. Its changing internal energy is zero for first option. Cyclic process, comma, adiabatic process. Second option, isothermal and adiabatic. Next, third option, cyclic process, comma, isothermal process. Fourth option, isochoric process, comma, isothermal process. So we already know cyclic process delta U is equal to 0, and which other process delta U is equal to 0. So let us take into consideration adiabatic process Q is equal to 0. So it is nothing but isothermal process. Adiabatic process is where delta U is not equal to 0. Cyclic process and isothermal process, because in isothermal process temperature remains constant. Temperature is proportional to internal energy. So since temperature is constant, we can say delta U is also equal to 0. So for cyclic process and isothermal process, always delta U is equal to 0. That is, change in internal energy is equal to 0. Next question. Let us see next question. In a closed system, option 1, which is correct, we have to see. Perfectly sealed. Second one, perfectly insulated. Perfectly insulated. Option 3, both 1 and 2. And fourth option, neither insulated nor sealed. Neither sealed nor insulated. So what is closed system? In which only heat is exchanged to the surroundings but not the matter. It is called a closed system. So in a closed system, which is the right option? Just let us see now. So in a closed system, so it is a perfectly sealed. It is not perfectly insulated. It is only perfectly sealed or perfectly insulated. Let us see now. So it is perfectly sealed because it is nothing but only heat is exchanged to the surroundings. Like water bottle you can take. Water bottle is perfectly sealed. It is a closed system. I hope it is clear. So listen to this class carefully. So in the next class we'll discuss more. So I'm doing this class. So what we have discussed today, let us know all these things. In the next class we'll discuss more. So I hope it is clear. Now I'll stop sharing this class. So